Hello everyone, my name is Sisvi Cristin from 10 IPAB. Today I will discuss about atomic structure. So this is the picture of the atomic structure. The orange is the proton, the blue is the neutron, and this is the nucleus. And the yellow and the outside one is the electron. So proton is the positively charged particle. Neutron is the zero charge particle. Electron is the negatively charged particle. And nucleus is the central core. So orbit. Orbit refers to the energy level which acts as pathway for electrons to spin around the nucleus. Orbital. Orbital is a region around the nucleus where electrons have the highest probability to exist. Brief history in the discovery of atomic models. First, Democritus, atom is a tiny indivisible particle called atomos. Second, John Dalton. Atom is a solid block of indestructible positive sphere. Third is Joseph John Thomson, discovery of electron using cathode ray tube experiment. Plum pudding model. Atom is like plum pudding, where the bread is the positively charged sphere, while the raisins are like the electrons embedded on the sphere. Fourth, Ernest Rutherford. Discovery of proton, discovery of neutron. He discovered that atom is mostly empty space. He conducted the gold foil experiment or alpha scattering experiment. Atom is mostly empty space with a nucleus made of positively charged particles called the protons with the electrons surrounding the nucleus. Fifth, Niels Bohr. Discovery of orbit or energy levels, shells or quanta, planetary model. So this is the picture of the Niels Bohr. So condition of electron, ground state. Ground state is the condition in which the electron is found on its original energy level. An excited state is the condition in which the electron receives an extra energy and jumps into a higher energy level. Bohr's model. So Bohr's model, has the nucleus and has a shells and it has 1, 2, 3, 4, 5, 6, and 7. So first is also called as K and can hold up to 2 electrons, and the second one, also called as L, can hold up to 8 electrons. Third, called as M, hold up to 18 electrons. Fourth, and called as N, can hold up to 32 electrons. Fifth, or O, can hold up to 32 electrons also. Sixth, or P, can hold up to 18 electrons. Seventh, or Q, can hold up to 8 electrons. So example, first, show the Bohr's model of calcium, or Ca. This is the nucleus and the electrons is 20. So we draw the shells first, then 1, 2, 3, and 4. Then we write this 2, 8, 8, and 2. So the valence electron is 2. We get it from the last number. The second example is Cs or cesium, and the electron is 55. Then we draw the cells first. It has 7 shells. 1, 2, 3, 4, 5, 6, and 7. So 2, 8, 8, 18, 18, 8, and 1. So the valence electron is 1. Sublevels or subshells refers to the shape of the orbitals around the nucleus where electrons are found. There are 4 sublevels or subshells. First one is sharp or S. It can hold up to 2 electrons. Second is principal or P. Could hold up to 6 electrons. Diffused or D. Could hold up to 10 electrons. And last one is fundamental or F. Could hold up to 14 electrons. And the orbital 1, 3, 5, and 7. So sharp has 1 orbital, principal has 3 orbitals, diffused 5 orbitals, and fundamental or F 7 orbitals. Guidelines in filling electrons among orbitals. First one is Aufbau principle. Electrons will occupy the orbitals having lower energies before occupying higher energy orbitals. According to this principle, electrons are filled in the following order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p. So this is 1s2. So it has an up arrow and down arrow. 2s2 also has an up arrow and down arrow. 2p5. So we fill the up arrow first. So 1, 2, 3. And then we fill in the down arrow 1 and 2. So there is 5. Then the second is the Pauli exclusion principle. A maximum of 2 electrons, each having opposite spins, can fit in an orbital. So it has the maximum of 2, so it must be an up arrow and down arrow. Hund's rule. Every orbital in a given subshell is singly occupied by electrons before a second electron is filled in an orbital. So 1s2 also have an up arrow and down arrow. 2s2 also an up arrow and down arrow. 2p4 an up arrow, up arrow, and then we fill in the down arrow. So it has 4. Energy level. So energy level has 7. 1, 2, 3, 4, 5, 6, and 7. First one is K. Second is L. Third is M. Fourth is N. Fifth is O. Sixth is P. Seventh is Q. Then we will make it from here, 1s2 and going up, 2s2 going up, 2p, 3s going up, 3p, 4s, going up again 3d, 4p, 5s, then going up again 4d, 5p, 6s, going up again 4f, 5d, 6p, 7s, then going up again 5f, 6d, 7p. And this is the mnemonic device. Then this is S, S, PS, PS, DPS, DPS, FDPS, FDPS, and FDP. Electronic configuration is a way of distributing the electrons in each orbital around the nucleus. Example number 1, calcium or Ca. It has 20, so 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. And the valence electron is 2. We get it from the last number, the last shells. So second example is bismuth or Bi. So it has 83, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, and last 6p3. So the valence electron is 5. From here, 2 plus 3, so 5. So the third example is Pb or lead. It has 82. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, and 6p2. And the fourth example is Fr or francium. It has 87. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, and 7s1. Next example is Fl or flavorium. It has 114. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p2. And that's it, the example. So that's it for today's discussion. Thank you for listening.